What's up guys? In today's video, I'm going to show you how to use pre-processing on images to make your object detection better in OpenCV. Specifically, I'm going to be talking about HSV thresholding. Hey, I'm Ben, this is Learn Code by Gaming, and we are up to part number 6 in the OpenCV for Video Games tutorial. So to recap, in the previous videos we talked about how to apply OpenCV's matchTemplate to video games in real time in order to detect objects that we want to find on the screen. And what we have so far works perfect in some situations, but it falls short with more visually complicated games. So one way we can address that is by filtering out objects we're clearly not interested in before we ever send the image to matchTemplate. For example, if the object we want to detect is blue, we can just remove everything that isn't blue from the image. Another thing we can do is oversaturate our image, which will exaggerate the differences between different types of objects. The net effect of this should be that we can get more positive identifications without also increasing the number of false positives. Alright, so in our code, we're going to pick up exactly where we left off, and all of our work today is going to be inside the main file and then the vision class. And then before we get into our image preprocessing, the first thing I want to do is refactor this find method. So right now, find is a rather large function. We're calling matchTemplate in it, we're grouping the rectangles, we're finding the center point of those rectangles, we're doing a bunch of debug output, and I'd rather split all these different things into their own methods. And by doing this, it'll set us up to potentially apply multiple different types of filters and mix and match them in the future. And so by refactoring this find method, it'll give us greater flexibility. So I think I'm going to keep this find method to do our matchTemplate call, but I'll get rid of the debug mode parameter. And I think I'll cut this off right where it has this list of rectangles. And I'll just return those. And I don't want to lose the rest of this functionality, I just want to move it into other methods. So one of the things this code is doing is it's determining the center position of a bunch of rectangles. So let's make a method to just do exactly that. We'll give it a list of rectangles, and it'll return a list of center positions. Alright, so now we've got this much more compact method, and it just does one thing. And the last thing this code did, it was showing our original image, but with the rectangles or the crosses drawn on it. So let's split that out into two different methods. We'll have one where we draw the rectangles on an image, and another where we draw the crosshairs on an image. And instead of having IamShow as part of the debug code, let's go ahead and make that the responsibility of the main file. Alright, so here's what I came up with. For draw rectangles, we're going to give it an image to draw on, and we're also going to give it a list of rectangles. And then the code inside is pretty much the same as before to draw those rectangles. And instead of calling IamShow, it's just going to return that resulting image. And then draw crosshairs is the same, except we give it a list of points instead of a list of rectangles. And now we need to update our main file to work with these new methods. So find still takes a screenshot and a threshold, but it no longer has this debug parameter. And it no longer returns a list of click points, instead it returns a list of rectangles. And this no longer displays the processed image, now it's just doing the object detection. And now that we have those list of rectangles, drawing those onto our image is now a separate step. So now we call draw rectangles, we give it our screenshot image, we give it the list of rectangles, and it's going to return an output image. And finally, it is now the responsibility of the main file to call IamShow to show that image. So fundamentally, nothing's changed. We've just refactored our code, and if we run it, it should work just the same as before. So I'll run this to make sure it's still working. And you can see it's still operating the same as it was before. So now our goal with the rest of the OpenCV series is to do some pre-processing on this screenshot image before we ever send it to the find function that will make the find function work better. And the first thing I want to try is a color filtering technique that knocks out all the colors we're not interested in. And OpenCV has an official tutorial on how to do this, so if anything I say doesn't make sense, you might want to check out this article too. Theirs is called Thresholding Operations Using InRange. And they've got some images here to help you understand the difference between an HSV image and an RGB image. So up to this point, all the images we've been working with have been in BGR format, which stands for blue, green, red. And if we were interested only in blue objects, we could just set all of the G and the R values to 0, and we'd be left with only the blue pixels. But any other color besides those three are going to be a mixture of those three colors, and so they're a lot harder to isolate using the BGR format. So what we're going to do is we're going to take our image and convert it to HSV format. That way the hue or the color is just a single value we have to worry about. And then it also makes it easy for us to increase the saturation and the value because those are isolated too. So while it's possible to do color filtering with the BGR images, it's just a lot more convenient in the HSV format. And doing this filtering itself isn't terribly complicated. You just convert to HSV format using convert color, and then you'll call cv.inRange and apply your filter to it. But it becomes really tedious to try to figure out what exactly you should use for all these low and high parameters to make your filter. So in the example tutorial here, they've created track bars on a GUI interface. What that allows you to do is you can move the sliders to adjust your low and high settings for your filters in real time. And I think that's a pretty good idea, so let's go ahead and use the same technique. So the first thing we need to do is we need to build a GUI window, and this is all built into OpenCV. And this window will need a name, and we'll reference it by that name. So let's go ahead and make that a constant on the vision class. And then I'll create a new method to build the GUI. So here you can see the GUI code. I just create a window, and then I resize that window, and then I add a bunch of track bars to it. And I've set the minimum and the maximum value on those track bars. And for the maximum value track bars, I've also initialized those to be all the way over to the right instead of at the beginning. And the one thing that needs a little bit of explaining is this nothing function right here. So this create track bar function, it requires you to pass in a callback function to it. And then anytime a track bar is changed, it'll basically run that function for you. And in our case, we're not going to use this. We're just going to look up the track bar positions when we need it instead. But this isn't an optional parameter. We have to give it something. So I've just created this nothing function to pass in so it's happy. And this method won't do anything yet, or it won't control anything. But let's go ahead and call it in main just to make sure that we are seeing the GUI that we expect. So outside of the main loop, I'm calling init control GUI on our limestone vision object. And when I run this, you can see that we have this GUI window over here with all of these sliders. Now, because there's so many values here with these track bars, instead of keeping track of each one of them individually, I think what I want to do is create a custom data object that will just contain the state of all of these sliders. So I'll create a new file and I'll call it HSV filter. And to create a custom data structure in Python is really simple. You just create a class. And I've just created a constructor that will save each one of those slider values to a different property. So the next thing I want to do is over in the vision class, I want to add a method that will return an HSV filter object with the state of all of the slider values. So first we'll need to import our new class. And then I've decided to call this new function getHSVFilter from controls. And you can see this simply initializes a new object from the HSVFilter class. And then it populates each property with the value from the track bars using this getTrackBarPosition function. And it will return that HSVFilter object. And each one of these strings that identifies a track bar needs to correspond with the strings that we used when we created the track bar. So those are just the names of those track bars. So now that we can get the positions of all of those track bars easily, let's write a function to actually apply that filter to our image. So I've decided to call this method applyHSVFilter, and it's going to take the image that we want to apply the filter to, and then the HSV filter itself, I'll make that optional. So if we have a predetermined filter that we want to apply every time, we can go ahead and pass that in. Otherwise, if this is set to none, we'll go ahead and use the values from the getHSVFilter from controls to build our filter. So the first thing we need to do is convert our image into HSV format, and we know how to do that from the official tutorial that we saw earlier. And then if we haven't been given an HSV filter object, let's go ahead and get one from the function that we just wrote. And then this is the code that will actually apply the min and max values from our filter. So we'll have a minimum hue, a minimum saturation, and a minimum value, and that'll all be part of one NP array. And then same for our maximum values, we've got the max hue, saturation, and value. And then just like we saw in the official tutorial, we go ahead and call cv.inRange to apply to our HSV image the lower and the upper arrays. And then if we take another look at that official tutorial, when they call inRange, what that actually is returning is this frame threshold. You can see in the inRange documentation, it says it checks to see if an array element lies between the elements of the other two arrays. So what it's going to return is more like a mask, where the pixels that are in range are going to be a 1, and the pixels that are out of range are going to be a 0. And what you'll end up with the result from in range is a black and white image like this, where again the white pixels are inside of the range and the black pixels are outside of the range. So this last line here, where I'm calling bitwise and, what I'm doing is I'm taking that mask and I'm applying it to our original image. And anywhere where the mask is 0, our resulting image will also be turned to 0, so those pixels will be made black. And anywhere where our mask is 1, it'll basically ignore those and it'll leave those pixels alone. And then the final step is to convert our image back into that BGR format and return it. And if you notice, in our original GUI that we created, I added sliders not only for the HSV min and max, I also added sliders to add and subtract to the value and the saturation. So with those, what I'm hoping to do is mostly add saturation and value to brighten up the image and to increase the contrast between the different pixels. And I think that'll help us get better results. So in apply HSV filter, we need to write that code to increase or decrease the saturation in the value by the value that our track bars are at. And that should be pretty simple. For example, if we want to increase our saturation value by 10, we should just be able to add 10 to each one of the saturation channels. The one thing you need to watch out for is if we already have a pixel that's at 255 saturation and we add 10 to it, we don't want that to go up to 265. We want to keep that at the maximum of 255. So basically, we don't want to go above or below the maximum when we're adding or subtracting these values. So here's a method that will do that for you. It's called shift channel. And I just found this on Stack Overflow because I was too lazy to try to figure it out myself. You can see it's not too crazy. It's either just adding or subtracting the amount that we want without going above or below the limit. And I want to apply those adjustments before we do the thresholding, so that'll go right in here. And to do it, we first need to split the HSV image into its component HS and V values. And then we can shift the saturation and the value corresponding to those sliders, or to the HSV filter object that we were given. And then once we've made those adjustments, we can just merge it back into a single image. So now we're ready to go try this out back in main. And I'm going to disable the object detection stuff for now. Let's first just see what it looks like when we apply a filter to our screenshots. So I'm calling apply HSV filter, sending in the raw screenshot, and I'll have that be our output image. So we'll run this. And let's just try out all the different sliders and see what they do. You'll want to test out every single one, make sure they all work. And you can see by adding value, we can really brighten up our image, or we can subtract value to really darken it. We can also add saturation to really increase the contrast between the different colors. Or if we subtract saturation, it goes more to grayscale. We can also adjust the value minimum to make all of the darker pixels go all the way to black. Or we can adjust the value maximum to take all of the brightest pixels and turn those black. Same with saturation, we can use the minimum saturation to take all of the grayscale pixels and make them black. Or pull down the saturation max and take all of those really bright saturated pixels and turn those ones black. And for the hue, you kind of want to think of hue as a color wheel. So if we really narrow down the hue, so here between 0 and 17, we can see mostly red type colors are coming through. But if I move that band over to the right, you can see now I'm getting mostly the green colors coming through. With the hue between 90 and 130, that seems to be about the blue range. And right at the top of the hue, it seems like we've gotten back to maybe the purpley reds. And to be more certain about the colors that we're selecting, maybe we add a little bit of value and a ton of saturation. And now when I play around with the hues, you can see the greens really jump out of there now. Same with the reds. Increasing the saturation makes that a lot easier to isolate. Now you can more easily see at the top of the hue range, that is kind of the more purpley reds, versus at the bottom of the hue range, that's kind of the more yellowy type reds. And once you have some sense of what the different filters do, what I want you to do is to try to pick an object on your screen and try to move the filters to isolate that object. So for example, let's try to isolate this fire pit right here. So I'll generally start by increasing the value a little bit to make it brighter, and then increasing the saturation. And then just kind of play around with the sliders until you just see that fire pit really jumping out and nothing else. Don't forget to use the saturation and the value sliders too. So this looks pretty good. You can see I've isolated the fire pretty well. And from that initial more complicated image that we have, you can see that we've eliminated a lot of it right off the bat. And what we're left with is this image where a lot less is going on. And so the idea is if we feed this into matchTemplate and we give it a needle image that is maybe just a crop out of this fire pit right here, that's going to be a lot easier for it to find versus what we initially started with. And it's easier because there's a lot less going on, and there's a lot less chance for a false positive. And even though some other things on here, like this button, are the same color red as the fire pit, you can see that the outline of it is clearly different, so hopefully matchTemplate knows not to match those up. Alright, so let's try this out in game. I'm going to try to isolate this limestone over here. Alright, so once I got some settings that I like, I'm going to take a screenshot. And I'm going to crop out the object that I'm looking for. And you also need to remember to write down or save all of the values of these sliders, because we'll be making an HSV filter using those settings. Now in main, we'll need to remember to import the HSV filter class. And then we'll update the needle image to use our processed image. And this is what that needle image that I cropped out looks like. And then I'll go ahead and create that HSV filter object using the values from the sliders that I saved. And then we can just pass that filter into apply HSV filter. Now when I run it, you can see that that filter is automatically applied, and it doesn't matter what I do with these sliders anymore because I gave it that set filter. And you can see that the day-night cycle is already kind of changing what it looks like when I apply these filters. So I'm kind of trying to move a little fast here. So now I'm going to reinstate the object detection stuff. I'm going to save this one as processed image that we get back from applying the HSV filter. And then I'm going to go ahead and give that to the find function. So that way matchTemplate will be using this processed image as the haystack, and then the needle image will be this one that I cropped out. And then when we draw the rectangles, we'll go ahead and use the original screenshot for that. So even though we're getting the rectangles using the process stuff, we'll still, on our output, draw the rectangles on the original screenshots. But if we wanted to see what the processed images look like at the same time, we can just create a new window for that. So now when we run this, we'll see both outputs. So now you can see we're processing the image to get this, and we're using the needle image that looks something like what I cropped out here. And over here, you can see that when we pass that in to find, matchTemplate is finding that successfully. And that's already working a little bit better. Here it's finding 2 examples of that limestone instead of just the one. And what this allows us to do is, because there's less chance that we'll find false positives, we can lower our match threshold a little bit. And as we lower that, we should be able to match more of the limestone deposits that we weren't matching before. So you can see as I run around here, it's doing a much better job of matching some of these limestone deposits. Of course, we still have one false positive here, matching with this wheelbarrow. So it does look like it needs a little bit more fine tuning still, both on our HSV filter and on our matchTemplate threshold. And that's about all there is to know about HSV thresholding or color filtering. And before you go, there are just two more changes that I made to the find function that I want to tell you about. The first is if find finds lots of results, it'll really slow down your program, and I've actually had mine lock up before. So I've added this optional max results parameter. It'll default to 10. And then down at the bottom of this method, if you have more than that maximum number of results, it'll go ahead and just truncate it. So this way, if you're playing with your match threshold and you get a little bit too aggressive with it, it won't lock up your program. The other change I made is back near the top of the find method. If we don't find any locations from matchTemplate, it's going to go ahead and return an empty array. I was experimenting with using multiple needle images and then combining all of those find results together. So all of those list of rectangles, I just wanted to concatenate them together and output them on a single output image. But when I did that, when I tried to join together a list that did have rectangles and a list that didn't, it was giving me an error. And I found you can fix that just by reshaping that empty array before you return it. So that's what this is about here. So go ahead and give this method a try. You'll find that it works really well in some situations and not so great in others. For example, in Albion, it works pretty good right now, but we still haven't gotten over the issue with the day-night cycle. And that's because that cycle causes the colors to shift. So I've got an idea for another processing technique to try out in the next video to try to solve that. So that's about all there is to know about the HSV thresholding technique. I hope you guys are able to find some success with it. In the next video, I've got one more pre-processing strategy that I want to show you. So if you like this video, that one should be interesting for you too, and I'll see you then. Oh yeah, and all of the links to this code is in the description, or you can just go to the Learn Code by Gaming GitHub and you'll find it there. You can also go to learncodebygaming.com. I've got articles there for all the videos that I make. I figure I write scripts for all these videos anyways, so if you prefer to read this stuff, you can find those there in written form. So yeah, go check out learncodebygaming.com if you haven't already.